The question is how my valid transaction gets included in a blockchain. Here's what would happen. All the new transactions go to a new block that is not still chained. To chain the block, first we need to have something called proof of work. And guess what? We need some folks called miners to get that proof for us. Let's see what does this mean. The miner gets the new block, which includes recent valid transactions, plus the ID of the previous validated block. The only job for the miner is to find, or better to say guess, a number that when added to the block information and applied the magic function SHA-256, it generates an output, usually referred to as hash, with a fixed length that starts with certain number of zeros. For example, let's say 20 zeros. The rest doesn't matter. The magic number is basically the proof of work and is referred to as nonce, or number used once. So the whole Bitcoin mining is all about who can guess the magic number first. As soon as the lucky winner finds the magic number, he adds it to the block and broadcasts the victory to the network. Finally, everyone's add the valid block to the end of the chain, and this block is set. All the other miners immediately stop working on that block and start trying to figure out the magic number for the next block, which includes the new transactions. You might say, why not faking the hash by generating a number that starts with 20 zeros and the rest is bunch of random numbers, and then doing the reverse to find the magic guess? You wish. As I mentioned before, SHA-256 is not reversible, and the only way to find this number is to go this way and keep guessing. To guess fast, or technically to check a lot of numbers per second, you need lots of computation power, which is expensive and energy consuming. That's why the Bitcoin mining is really hot in the countries where the electricity is cheap. Over time, as the computational power goes up and more miners join the guessing game, the Bitcoin algorithm increases the number of zeros at the beginning of the hash to make it more difficult to guess. To give you a rough estimate, the chance to generate a hash that starts with 24 zeros is roughly equal to the chance of winning a lottery jackpot when you select 6 numbers out of 49. Now, if the number of zeros goes up to 30, the chance is 72 times less than winning a lottery. The other question is, what is in this game for the miners? Well, when they find the lucky number, they add a special transaction to the block to claim their reward. The reward to find the magic number was 50 bitcoins when the Bitcoin was invented in 2009. Every 4 years, the rewards gets cut by half. Now it's 6.25 bitcoins. Besides the reward, for each transaction included in the block, the miners also collects a small transaction fee, which is like a tip from the sender who is pseudonymous to the miner. This tip incentivizes the miners to include my transactions in the recent block. It's like if you're a waiter in a restaurant and you know from the past that this lady is very generous and she's gonna tip you a lot, most likely you provide a better and faster service for her. The second question is, why the hell do we need this useless, stupid number at the first place? Well, if the number doesn't exist, everyone could log a bunch of fraudulent transactions together in a block and send 1,000 blocks to a network in a fraction of a second. This makes the chain so messed up that would become impossible to untangle, and the whole system becomes unreliable and worthless. The exhaustive computation enforced by the Bitcoin protocol makes it very time-consuming to find the magic number. For this reason, it takes roughly about 10 minutes to create a new block and add it to the chain. This gives enough time to the network to validate and digest the new block. It's very interesting to note this cryptography ensures that each block of transactions is bolted onto the last block in a long, transparent and immutable chain. Imagine a thief wants to change one of these transactions even slightly. For example, changing 2 to 20 bitcoins. In this case, as the content of the block is changed, the hash of this block generated by SHA-256 is changed as well and not valid anymore. So the hacker needs to guess the magic number again from square one. And even worse, as all the blocks are chained and each block has the ID of the previous one, if you change anything here, you need to redo the whole work to find a special number for the altered block and the blocks after that. In this scenario, any fraud requires infeasible amount of computations, which is sometimes referred to as 51% attack, i.e., you need to control 51% of the computation of the whole planet, and you must be extremely lucky to do it. Finally, let me explain why there are just 21 million bitcoins to mine. Because of the block reward that miners claim, the total amount of bitcoins in our economy increases with each new block. Roughly, every 10 minutes we get a new block. Approximately, there are 52,000 10 minutes chunks in a year. Every 4 years, the reward gets cut by half. This results to 21 million bitcoins. This limitation makes Bitcoin more attractive as an asset. In theory, if the demand grows and the supply remains the same, the value will increase. Thank you very much for watching this video and I hope you find it useful. This video is created by Castofly, a software platform that empowers educators to easily create content without any audio or video editing background. As Castofly is an early stage startup with limited marketing budget, we heavily rely on your generosity to spread the word about our platform. If you enjoyed this video, please share and like it with your network, and if you're a teacher, check out our website to generate content and share your wisdom with everyone out there who is hungry to learn. Thanks again and see you soon.